and welcome to this quick tool review. This time around we have another really interesting tool to take a look at from Tangent Engineering. Actually, it's 4 variations on the same tool, and just to give you perspective, I thought I'd show you another tool from Tangent Engineering that I use all the time. So over at the mill, we have the standard quill handle here, and it's what I normally leave on the mill because it stays out of the way. However, if you need to do any amount of drilling at all, it is really inconvenient. You find yourself constantly repositioning this so that the handle doesn't end up in the way, or so you can get enough force on the handle. Like if you want to drill something and it's starting here, you got to set the handle there. I'm sure you're all aware of this. So there's another solution that is far superior to the standard quill handle for situations like that. Thanks to Tangent Engineering, who sent me this a long time ago. I use this every time I'm drilling more than 1 or 2 holes, and it is fantastic. It goes on and off with a wing nut, which is right here, so it's quick on, quick off. If you're drilling a lot of holes, it's very easy to have any position around the entire circle to have good force control on the quill with. And so this is a fantastic tool, and I really appreciate them sending this probably a few years ago now. This has been a great tool. So let's take a look at the new tool he's come up with, which is also very creative. But before I get into the tool that he made, let's get into the problem that it solves. So here we have my lathe, and a really standard problem that you run across is wanting to set your compound to a specific angle so that you can cut a taper. Well, you could start with the really inaccurate way, which is using divisions on the compound itself, but you're not going to get better than a degree that way. Probably not anyways. And so I came up with a solution a while ago, which I'll show you right now. Here's my solution, this big heavy piece of steel here with 4 magnets glued into the bottom, and sits on top of the compound like so. Doesn't move, and I ground both sides, the back where it meets up with the compound and this side here. Then what you do is you stick a very small SINE bar right here. So you set a SINE bar here, set a set of gauge blocks, but it's very limited. The angles you can deal with, are what the SINE bar will still be able to fit a stack between here and here on, and then you run an indicator along here, and that was my solution, and it works okay. However, Jimenos over at Tangenteering came up with a much better solution. Jim's solution comes in several parts, so let's take a look at the first and primary part. So what he very generously sent me was 4 different sizes of lathe compound SINE bars. 3-inch, 4-inch, 5-inch, and 6-inch SINE bars. Each SINE bar kit comes with everything you need to make it extremely easy to cut tapers on the lathe, although I think these could be used elsewhere as well, but they were designed predominantly for the lathe. He has another tool that he's coming out with very soon that'll let you use these very same bars easily on the mill in your mill vise to set an angle. But right now, this is a very interesting designed SINE bar. So you have 3 magnets, comes with 4 nylon screws for leveling if need be, and 2 very precisely placed ground pins. And I was asking him how he did this, because if I was making this, I would center drill, and ream. He says, no, that's not an accurate enough way to place holes, and the hole placement of these, the center to center distance needs to be very accurate. He actually uses a jig borer, so they drill, bore, and then ream the holes. So the placement is very accurate, which is pretty awesome. And I don't have access to a jig borer, so I couldn't reproduce that. Also included in the kit are all of these tables. Now I made larger versions of these tables, so let's go take a look at them. Here is a larger version of the Morse taper chart. He's got Jacob's tapers, Brown and Sharp tapers, and Jarno tapers. And each one of these kits comes with all of these in smaller form. And what makes these so amazing is you don't need to do any math to do all the basic tapers. So if we want to do a Morse taper number 4, like my tailstock uses, the large end is 1.2310 inches. The small end is 1.02. So if you want to make your own gauge to go, no-go gauge, you know that distance, which is really nice. 4.06 inches, taper per foot or taper per inch if you're interested in that, and the angle. But that angle is actually unnecessary because guess what? If you bought the 5-inch sine bar, you go right down here, there's your gauge block stack, 0.1298. You don't need to do any work at all, no math at all, and you're done. Over here, the 3-inch sine bar, 0.0778. 0.10384 for the 4-inch sine bar, 0.15576 for the 6-inch sine bar. So everything's done for you for all the tapers. That is another aspect that makes these a really convenient product. All right, so let's pick Morse taper 4 here, since that's what my tailstock uses. And since I have all 4 sizes, I can try and pick the size that I can get gauge blocks to equal this size. So 0.1298 is really close to 0.1300, and I'd only be off by 0.2. So I'll use the 5-inch sine bar, because here's the deal. When it goes less than 0.1, even the large gauge block sets, they don't have a lot of options below 0.1. So you can't easily make these sizes that they're talking about, like 0.0752. I don't even have 0.075. I have a 0.050, but no 0.075. So in order to do this, here's a thought. Hey Jim, you know, for your sine bar sets, you should sell a complete set of gauge blocks pre-ground for all of the basic tapers for a specific sine bar set. That might be a really good product. I don't know if you have the capability in your shop. I bet you do. It might be a good product. Maybe it's too expensive. I don't know. But making some of these smaller gauge block stacks are impossible with a normal gauge block set. So we're going to go with Morse taper 4. And we're going to go for 5-inch sine bar, 0.130. All right, so I have a sample piece of material over here. I'm not actually going to turn this into a taper, but I want to show you the various methods and show you how Jim's sine blocks can make that very easy to set up. So there are 3 basic ways of cutting a taper on a lathe. The first way is if you happen to have a taper attachment, then you just set the taper directly on the taper attachment. All cutting is normal, saves you a lot of hassle, but most of us don't have that. So the second solution is if your compound, the range of your compound, the range of motion of the compound is not long enough. Let's say I need to turn a 12-inch taper. This compound has a 6-inch range or so. I couldn't turn a taper that long. So the way you do that would be put your test piece between centers and then shift your tailstock off the center line to match the half angle of the taper angle that you're interested in. So if the overall angle of the taper was 3 degrees, like it is approximately for a lot of Morse tapers, then you would shift it off 1.5 degrees, so the distance it would take to move this test sample 1.5 degrees. All right, so when you're trying to turn between centers, you would take a couple passes at 60 degrees, which you could use the Tangent Engineering lathe compound sine bars to set your 30-degree angle, which is half the total angle here, and do a pass really quickly across this to get it right at 60 degrees. Then you would use your 60-degree center drill to cut both sides and turn it between and get your part between the centers. And then you would shift your tailstock off of center by half the total angle of the taper. So here's a Morse taper 4, and the angle is just shy of 3 degrees if I remember right for the whole angle. So you want to turn half that angle because it'll end up doubling it. So about 1.5 degrees, something approximately in there. Now when you shift this off of center, this 60-degree tailstock live center is not going to meet up perfectly with the 60-degree hole you have in here. By the way, I forgot to put the lathe dog in here just for completeness. If I put the lathe dog on here, then that will allow you to drive the part, but I forgot to put that on there just so you can see it. So when you shift this guy off center here, the 60-degree taper here is no longer going to meet with the 60-degree taper there. So Jim mentioned a tool that I had never seen before, and that is the radius center drill. So if you'll notice, here's the standard 60-degree center drill, and here's the tapered center drill, radius center drill. And the advantage is that when you shift this guy off center, this still makes contact all the way around. Less likely you're going to wallow out a hole in your part. Now, we can take advantage of Jim's sine bars here, but to set our 30-degree angle, for this, but we can't use it to set the taper here. And there's another tool possibility for Jim, that he can create a V-block that clamps on the part with a clamp underneath that lets you use his taper attachment. We can run an indicator up and down here to get that angle right on the taper we need. That's another product idea for Jim. I think he should build one. If you're looking for the radius center drills, you can either get them from Jim or McMaster Carr carries them. That's he even gave the part number for it. So I picked up a whole set of various sizes because I hadn't run across them before, and they're pretty darn handy. The final approach is if the taper, like the Morse taper in my case, Morse taper 4 is like about 4 inches long. My lathe compound will do a 4-inch swing, so I can actually turn that far. If you're going to do that way, then I'm going to actually go through all the steps to show you how that method works, because that uses Jim's SINE bar in the method that he was intending with all those charts. So let's set that up. Step number 1, you load your part with some extra material in your chuck. In this case, it's a 6-jaw because that's what I have on here, but you could use a 4-jaw or a 3-jaw. All of those would be adequate. Next up, you take a facing cut, and you take a very light cut so that you don't have to worry about any chatter for this thing flexing, because we are much over 2 times the diameter out. So we're just trying to clean up the end. Next up, we use a 60-degree center drill because we're going straight in with our tailstock. And we cut a relief for with a 60-degree end mill. If you want extreme precision, use a very small boring bar, set your compound at 30 degrees, which is half the angle, and you go and clean up this center drill hole so that it's right on center at 30 degrees. Because when you're boring, you've got a much better chance of it being right on center than you do even with a center drill, because center drills aren't perfect and they don't always drill perfectly on center. So rather than show that, I can explain that. You use a very small boring bar to do it, and you just do a skim pass to clean this guy up. Rather than skip a step, I use Jim's SINE bar to set the 30-degree angle. Don't worry about that. I'll show you the setting an angle coming right up. And I'm going to just clean up the center drill hole, which I've never actually done this before, so it's kind of interesting. I'm going to clean up the center drill hole here just to make sure that it's at exactly 30 degrees. And we're going to be using our SINE bar. We're going to be using our compound just to go in and clean up that hole. And I'm taking a very, very light skim cut, and we should be right on 30 degrees. Okay, now we're ready to go to the next step. Next up is using the SINE bar to set the angle, and that's really straightforward. You've got 2 pins that are hardened and ground right here, and 3 very powerful magnets. Just set that guy down there, make sure the front pin is touching. Slide this back until it presses up against the gauge block. The magnets hold it very firmly in place. Now we get an indicator and run this back and forth until it reads 0 going from side to side. This is the 5-inch SINE bar. All right, so we've got our indicator on here, and I suspect it's nowhere near horizontal yet, but you walk your compound in, set 0 on one end of the bar. You go to the other side. Now you notice that it's dropping, it's going down as I head in this direction. And I got to be careful that I'm not touching like I just did. I got to be careful that I don't rub into my my cross slide like I did. So let me try that again. It can be tricky. Having a longer Noga arm can really help right here. Okay, set my 0, traverse. Okay, notice it's going up, which means that my compound needs to be tapped in that direction. So I'm gonna move it a bunch. I'm gonna come back to 0 here, refine my 0, traverse again. Now I went too far, it's going down. Okay, and I bumped it again too. That's great. All right, so now I go this direction, the same direction it moved, to compensate. Set my 0, and we're pretty good. We're dropping a couple tenths there. So we'll come back here. We'll tap it a couple thousandths, re-0. So if the needle is going this direction, counterclockwise, I knock my compound towards me. If it's going clockwise, I go towards the inside or towards the center line of the lathe. There we go. Now we're not moving at all, more or less. And if I set this arm up right on my Noga correctly, we could traverse the whole 5 inches and see how good we are over 5 inches. It's pretty much not moving at all, but I'm going to run into this. I don't have a long enough arm. Getting the big boy in here might be really helpful, or something that sits across here the 2 ways, so that you can, that might be another tool that Jim come with, something that sits across your ways to set your magnet on, or something I need to build. But now my angle's set, so I can tighten down my lathe compound. So that's all there is to it. The way I've got it set right now, it's cutting from large to small down at this end. Now if you want it to be small to large on this end, all you would have done is you would have taken Jim's SINE block right here, and instead of putting the gauge block on this side, put the gauge block on this side with this side flat against the compound, and zero this out, and then you would have been on the other side of 0 for the compound, and you'd be cutting from small to large, which probably makes more sense. You don't necessarily have to do that way. You can cut a relief on this side and go large to small and work all day long. That's not a problem. But you can do both directions, especially for small angles. For greater angles, like 30 degrees or something, you probably wouldn't be able to get away with that because there just wouldn't be enough room for this all to work. The SINE, going this way from small to large, the compound's going to run into this guy right here. It's going to be a problem. Going back to turning between centers, not using your compound, the tool I was talking about would be something that would fit on top of your part, that would clamp on, and it would have a flat part on top that you could mount, that this magnet would adhere to, and you could set this SINE bar, maybe the 3-inch SINE bar, to this part. Let me grab the 3-inch. So smaller, something you could use the magnet on the 3-inch SINE bar, so it would have a flat surface here, and use gauge blocks there to set the angle so you can offset your tailstock. That would be a really handy addition for this tool. So I think Jim should make sets of gauge blocks that are for those really small angles, and maybe a fixture to fit on parts on the lathe so that you can also set tailstock offsets. In addition, he already has a tool coming out that clamps in the jaws of the vise over on the mill that let you use the SINE bar on that part so you can set the vise in your mill at an angle so you can cut tapers on the mill. All pretty awesome. Alright, so here's a little bonus for you. I didn't show you setting a 30-degree angle, and I felt guilty about that, so I'm going to do that right now. So here's a 5-inch SINE bar, and he doesn't have tables for common angles like 30 degrees, but it's really easy to calculate actually. So the SINE bar is a 5-inch SINE bar, so the hypotenuse is 5. SINE is opposite over adjacent, opposite over hypotenuse, and the hypotenuse is 5. The opposite would be your gauge block stack. So just to simplify that in layman's terms, with a 5-inch SINE bar, it's 5 times the length of the SINE bar, 5 times the sine of the angle, which is 30 degrees, and the sine of 30 is 1/2. So 5 times a half is 2.5. So a 2.5-inch gauge block stack should be more than adequate to get this right on 30. So once this is over here and this guy's on 30, you get this guy squared up, run an indicator, and you will find that you're right on the 30-degree mark on your compound. If you want to go the opposite direction with your compound, as I was discussing, then you put this side down and you put your stack under this side instead. Sorry, this is my work gauge block set, and the 2-inch gauge block is not in very good shape, and there is no 1/2 inch. I have a really nice set, but I wasn't bringing them over here because I keep dropping these. So once you get that set under there, then you zero this guy up. Now I'm 30 degrees the other direction. And that's what I was trying to show you early. Now you can see how this wouldn't be practical going from small to large in that direction if you're going to use your center for a large angle like 30 degrees or 60 degrees total. But if you were going to go for a much smaller angle, this might be okay because it won't run into it. But that's what I was talking about earlier. I mentioned that when you're doing large angles, the compound's going to kind of get in the way if you really try and do something like 30 degrees, because your center is going to be right on top of your compound. In summation, I think Jim over at Tangent Engineering has got himself a really great set of products here, and I think they have a lot of potential. There's use on the lathe in multiple scenarios if he makes the other tool. There's scenarios where you can use them on the mill and the milling vise with the new tool he's adding. And I think if he made the custom gauge block sets, that would be really handy. Although I just realized for these smaller numbers, you could use a gauge block combined with shim stock to get these thicknesses. Because the gauge block set, you have a 50,000th and a 100,000th, but you can't really do 0.07748. There's just no way. But with shim stock, you could probably get that within a 10,000th or two. So that's a pretty interesting option. So I just had a slap yourself in the head kind of moment, realizing I can get this gauge block sets to do very accurate small sizes like this. And how, you ask? Well, it's actually kind of surprisingly easy. So I've got here, this is 0.16296, which really is 0.1630, right? So how can I get to 0.1630? Well, I've got a 0.150 and I have a 0.113 here. And if I add 0.150 to 0.113, I get 0.263, which is only 100 thousandths over the value I'm interested in. Well, that's not right? How is that going to work, 0.263? Well, guess what? I can come over here and I can put the 0.263 over here, and I can take a 0.1 block, put it on the other side. That subtracts 100 thousandths off this side, and now I effectively have 0.163. So you can do differences between the two sides to get the total value you're interested in. So you can do it, and I didn't even think of that when I was doing the video the first time, so there's the solution. Bottom line is, I think he's got himself a really neat set of tools here with a whole bunch of possible uses, and I look forward to discovering more of them as time goes on. Thanks for sending them to me, Jim. I really appreciate it. And I think people out in the audience might really find a lot of good uses for them as well. Thanks for watching. Hope you find it useful. Hope to see you next time.